In this video, I'm going to have a look at fractions, what they are and how to use them, how to do mathematical operations on them. It's quite a big subject, so I'm going to split this into a few videos to make them shorter and more digestible. And this one is an introduction. The first thing is we need to be clear what fractions are and what they're about. And a fraction is a way of expressing a number that is less than 1. We're all familiar with the integers 1 and 7 and -6 and so on. But when we have something that's less than a whole number, we need fractions. That's the first thing to bear in mind. Fractions express quantities that are less than 1. Now, there's a number of different ways to express quantities that are less than 1, and two of them are using fractions and decimals. So fractions tend to look like this. Some examples of fractions, and decimals tend to look like this, and so on. And these both express the same idea, but in different ways. And indeed, you can convert from fractions into decimals and vice versa. So if we take the fraction 2/3 and the decimal 0.666 recurring, those actually are the same quantity expressed in two different ways. And we'll have a look at how we do the conversions from one to the other a little bit later. But I don't want to get into that right now. We're looking at fractions. So you'll see that all these fractions are written as one number with a line and another number underneath the line. And that's the way we write them. All the parts you may find in a fraction, a full written fraction, I'll give you an example, 1 of 1, -7.5. So this has got various parts. We've got the first part, which is the sign, and that can be, in this case, it's minus. If it's not present, it means it's positive. Obviously, if it's plus, it means it's positive as well. So there's potentially a sign. Then we've got, in this case, the number 7, which is not written over or under the line. This represents the whole number 7. And that is not a fractional part, but we may just be expressing a number that has, in this case, is bigger than 7. It would be quite limiting if we could only use fractions to express quantities between 0 and 1, but we can use it to express any quantity, in this case 7.5. This is the fractional part of the number, in this case 1 divided by 2. So you always have the line, and then you've got a number, we'll call that A over B, in the fractional part. So this is the fractional part, and the sign and the whole number may or may not be there. So that's why we can write a fraction as, for example, 1/2, or we can write it as 6.1/2, or we can write it as -6.1/2. and 1/2. These are all different, obviously, but just showing the different parts that we can have in each number. And if you're going to write a whole number with a fractional part, make sure you do it so the whole number is bigger. If we're going to write 6.5, for example, don't write 6 and 1/2 because we don't know where that 6 belongs. Is this 61 over 2? Is that what we're trying to write? Don't put it on the bottom or make it look as if it's attached to the bottom like that, because that could be mistaken for 1 over 62. So the proper way to write it is with a big 6 and then the fractional half a little bit separate and clearly distinguishing which is the whole number, which is the fraction. Ignore the whole numbers just for the moment, but remember that they are potentially there. And we're going to have a look at the fractional part. Mathematicians like to give things names, so when we have a fraction like 3/4 or 3 over 4, the number that goes on the top is called the numerator, and the number that goes on the bottom is called the denominator. And it's useful if you can remember those. It's not absolutely essential, but I will certainly be referring to them. Now, the denominator tells us how many pieces one whole thing has been cut into. So if we imagine we're talking about whole numbers of cakes, so here's a cake seen from above. It could be a pizza, it could be anything, it doesn't really matter what it is, but that's one whole one. The denominator in this case, which is a 4, tells us that this cake, pizza, whatever, has been cut into 4 pieces. So, and they're all equal size. So there we are, that's cut into 4 pieces. And the numerator, the number on the top, tells us how many of these pieces we are dealing with. In this case, 3. So if I shade these in, there's the first piece, the second piece, and the third piece. So we forget about this piece because it's not one of the 3. Of course, we could have chosen any 3 pieces. We could have chosen these ones. It doesn't make any difference. The quantity is still the same. So 3/4 means we've got this much of one whole one. That's what we're dealing with. When we say what this fraction is, 3/4, 3/4, that is equal to 3 of pieces where each piece is the size of a quarter. So let's just see what 1/4 looks like. So 1/4 is written like that. So let's have a cake and divide it. The denominator's 4, so we divide it into 4 pieces. And on the top there's 1, so we take one of those pieces. Doesn't matter which one we take. Let's take this one. So that is 1/4, or 1 piece where each piece is the size of a whole one cut into 4. And when we have 3/4, we simply take 3 of these pieces where each piece is the size of a quarter. So I've already shaded one here. If we were going to have 3/4, we'd simply shade 3 of them, or take 3 slices, and that would give us our 3/4. So we can see that when we express a fraction like 7 ninths. For example, this is telling us we've got 7 of the pieces. Each piece is the size of 1/9, and 1/9 is a whole one cut into 9 pieces. Probably won't be able to do this very well, but let's have a go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that'll do. And so we're going to take 7 of them. So that's 1, 2, 3, 4, 5, 6, 7. And that will be written, the ninths is the denominator, and over the top, each piece is the size of 1/9, but we've got 7 of those pieces, so we've got 7/9. That's how we would write the fraction 7/9. There is another way to end up with exactly the same quantity. In this example here, we've got 3/4. It's 3/4. And this is a slightly different way of thinking about how we achieve this quantity, but it is exactly equivalent. And this way consists of taking 3 whole cakes, 1, 2, 3, and we take 3 because we've got the number 3 on the top, and we divide this top quantity by 4. So if we divide 3 by 4, one way of doing that is to just simply divide each of these cakes up into 4 and then share those out equally between 4 people. Each person, first cake will be divided amongst 4. Any particular person is going to get 1 slice of that cake. The next cake, they'll get another slice from that one, and the last one, they'll get another slice from the last cake. So if we put all these 3 slices together, what we end up with is 3/4. That one there, for example, goes here. This one there will go there, and that one there will go there. And we can see that these are exactly the same. So we can think of a fraction as being, let's do a fraction, we'll just use letters, a over b. These could be any numbers. It's either a pieces where each piece is 1 divided by b, or we can think of it as a whole ones divided by b. They are equivalent and the same, but the reason for drawing attention to this is because when we convert from fractions to decimals, which we'll look at a bit later, we actually do this division. We treat the top as a whole number and divide it by b, and that will give us our decimal equivalent. A seemingly trivial but very important piece of information is that any whole number can be written as a fraction. So let's take the number 6. How can we write that as a fraction? Well, what we have to remember is that when we write it as a fraction, we're going to have a line, and what's on the bottom of the line is going to tell us the size of each piece, or how many one whole cake has been cut into to give us the pieces that we're going to be concerned with. And for a whole number like 6, the size of that each whole one has been cut into is simply 1. It's been left as one whole piece, and the number of pieces we've got is 6, of 6 whole ones, or 6 pieces where each piece is the size of 1 cut into 1. In other words, it hasn't been cut at all. Hasn't been cut into 2 or 3, it's just been left as 1. And it's true to say that 6 is equal to 6 divided by 1. And this is a very useful thing to remember. We could summarize that by saying any whole number A is equal to A divided by 1. And we will certainly use that, particularly when it comes to doing division of fractions. But useful to remember. Of course, we don't bother writing 6 divided by 1. What do we get if we divide 6 by 1? We get 6. And so we don't need to write any whole numbers as fractions, as that number divided by 1, unless we want to when it helps us. When we have a fraction, like, for example, 23 over 64, we have a bigger number on the bottom than we have on the top. If we had equal numbers, if we said like this, for example, 64 pieces where each piece is the size of one whole one that's been cut into 64 pieces, then we would have one whole one. So 64 over 64, and remember, if we do the division, like I said, here A over B is A. Whole ones divided by B, we can think of this as 64 whole ones divided by 64, and that of course goes once. And of course that's the same for any number like 17 17ths. That's also equal to 1. 23 divided by 64, this first one we looked at here, is going to give you an answer less than 1, because the whole cake, or a whole cake, has been divided into 64 pieces, and we've only taken 23 of them. But we can also have numbers on the top that are bigger than the number on the bottom. For example, we could have 64 over 19. And what this is telling us is that one whole cake has been divided into 19 pieces, and we've got 64 of them, which obviously is more than a whole cake. So that, when the top is bigger than the bottom, that gives you a number that is more than 1. And what we would do in this case is we would usually convert this into a whole number together with a fractional part, where the fractional part is less than 1. So it's going to have a smaller number on the top than we've got on the bottom. And we'll see how that's done in a while. But in this case, we would write that as 3 and 7/19. These are equal in amount. If you were offered 64 slices where each slice was 1/19 of a whole one, or you were offered 3 whole ones with 7 slices where each slice was 1/19 of a whole one, you'd be getting exactly the same amount of cake, assuming the cakes were equal size to begin with, of course. Fractions like this one, where the top is bigger than the bottom, used to be called improper, but these days they're called top-heavy. So those are the names that are used. I think you've probably come across this more often. We used to call them improper fractions, where the numerator on the top is smaller than the denominator on the bottom, are proper fractions, and ones where you have a whole number added to a fractional part, these are called mixed numbers. So I think that's enough for an introduction. Next, we'll have a look at how you use them and what you can do with them, how to manipulate them in another video. But I'll leave you with a quick summary of what we've covered so far.